Okay, here we go. I'm going to use just quickly Patrick and Annika for a quick example. You guys don't have to do anything, don't worry. All right, I'm going to go up to Patrick and I'm going to say, hey, what's the probability he picks an 8 out of the deck? What's the probability he's going to pick an 8 out of the deck? How many 8s are here? 4 out of how many cards? 52, right? So he picks a card, he picks an 8 out, he gets it, puts it back in the deck. It's not a magic trick, so don't worry. I go to Annika. What's the probability she now picks an 8? Same as Patrick's? Still. Did his event affect her probability? No. Okay, let's rewind here. Let's go back to the beginning. Probability Patrick picks an 8 again? 4 out of 52. Keep it. Don't put it back in. What's the probability Annika picks an 8? One's gone, and out of how many cards now? 51. So did Patrick's event affect Annika's event? Yes. Okay. So if they affect each other, all right, if one event affects the other, that's what we're going to call a dependent event. All right. So when Patrick kept his card, that affected Annika's probability of picking an 8. Those are called independent events. All right. Dependent. The first one I did with him, when Patrick replaced it, did that affect Annika's probability? No, so we call those independent events. All right, independent. So again, regroup real quick. Dependent means the second one is affected by the first one. Independent means there's no effect whatsoever on the second one from the first one. All right, so I gave you 3 examples. I want to know if they're independent or dependent. Ready to start, Isabella? Okay. Rolling a die, then a spinner. Does the probability of whatever I get on the spinner have any effect from rolling a die? Everyone agree? Absolutely not. That probability of whatever I ask for on the spinner is not going to change because I rolled a die. So, Isabella, what do we call it? Dependent or independent? Those are independent of each other. I'm going to skip over 2. You'll see why in a minute. Let's go right to 3. Here you go, Matt. You select a coin at random from your pocket. You put it back in your pocket and select again. When you select again, did you change the probability of any of those coins? No. So your first pick, because you replaced it, had no effect. So these are 2 independent events. Am I going too fast? Okay. Pick 2 flashcards from a stack of 30. Well, it depends. I'm going to give you, ready, the scenario. Let's say you do not replace the first one. So without replacing the first one, without replacement. Will that affect my second card, Vinny, if I don't replace the first one? You're darn right it will. So those 2 events would be what if I did not replace the first one? Dependent. Now let's say I replaced it. Replacing it. Reagan, is that going to affect my second flashcard probability? No, because I replaced it. So those 2 would be what? Independent. Okay. Everybody good on seeing if it's independent or dependent? Questions? Okay, well now, here's where we're going to go now. Find the probability. Patrick picks an 8, puts it back, then Annika picks an 8. So 2 8s in a row. What if he doesn't put it back? What's the total probability now? All right, that's where we're going right now. So let's go. Okay, go ahead. You can read your marbles. You guys, I told you guys the other day how I like to just take a bag and do it myself here. So 6 black, 9 blue. Like the color coding, you're welcome. 4 yellow, probably can't even see that one, but 4 yellow, 2 green. And you're picking 2 marbles out. And what are we doing with the first marble? Replacing it. Okay, keep that in the back of your mind. What's the probability now? So big P, probability you get a black, then a yellow in that order. A black, then a yellow. Ethan, let me ask you this real quick. How many times am I picking? 2. If you are selecting, picking anything 2 or more times, this is right above this example, I am going to multiply, not add, subtract, or divide. Multiply the two probabilities. Anytime, again, you are picking twice, selecting something twice or more, you're going to multiply the probabilities. So let's go, Lucas, here we go. What's the probability? What is it? Is that a black or a blue first? Black. Black marble, Lucas. Go ahead, out of the bag. What's my probability? 6 out of 21. That represents black. What are you doing with that marble, Lucas? Put it back. Now I need a yellow out. Anna, what's the probability now I get a yellow out of this bag? Out of how many marbles are still there? 21. And again, why the multiplication? You're selecting something twice or more. Oh, have some self-respect before you go into the weekend. Do not cross multiply. All right? There's no equal sign in between those two fractions. Numerator times numerator, denominator times denominator. Or just put it in your fraction template in your calculator right now. Get used to it. Let's go. Let's go. Get used to it. And again, I hope your calculator puts it in lowest terms. Megan, put it in lowest terms. 8 out of, sorry, I didn't hear the bottom. 147. Okay, so you have an 8 out of 147 chance of picking a black, then a yellow out of this bag. Okay, 8 out of 147 chance. Are we okay here? We okay? Any questions before I go a little bit more complicated on the next one? Anything else? We good? All right. Now let's say we don't put a card back. So let's go to Cindy. How many cards is she going to draw? Cooper, how many cards is Cindy drawing? 3. Everyone, hey, that's 2 or more, right, guys? So what am I going to do to every probability? Multiply them. All right. Anytime you're selecting 2 or more things, multiply all the probabilities. All right, so what do the 3 cards have to be? Well, she's got to draw a... What does she have to draw first? A 2. Then she's got to draw a 5. Ooh, and this is going to be the tough part when we get to it. Then it's got to be not a 5. Any card but a 5. And every time, what is she doing to each card? Keeping that sucker, right? She's taking it without replacing it. All right, so let's do this. Do I have this set up correctly? 2, 5. Yep, all right. Here we go. Picking a 2 out. Brianne, start us off. Probability I pick a 2 out. 4 out of 52. Everyone all right? I went over the cards yesterday. Okay, what is she doing with the 2 when she picks it? Keeping it, not back in the deck. Now she's got to pick a 5 with the remaining cards. Guys, how many 5s are still in this deck? 4. How many cards? 51. Gets the 5. Keeping it. Here's the tough part now. What's the probability she does not pick a 5 out of these cards that are still left? Don't yell anything out. Let's do the easy part. How many cards are left total? 50. Think about this. You already have a 5 out. How many cards are not 5s remaining in this deck? Think about it this way. How many 5s total do I have in a deck? 4, right? 1's out, so how many are still in this deck? There's 3 5s in this deck out of the 50. So how many are not 5s? 47 cards. Because usually, again, let me go through that a little slower. There's 4 of them in the deck. I took 1 out, meaning there's 3 still in here. 3 out of the 50. So 3 out of the 50 tells me 47 of them are not 5s. And what am I doing to each of these probabilities? You're picking more than twice, so we're multiplying them. So go ahead, lowest terms. I believe some of your calculators will not be able to handle putting it into a fraction, so if you want to leave the decimal, that's fine. I have it as a fraction, though, if you want to write it like that. So if your calculator does not leave it as a fraction, it's fine. I understand some of the numbers get too large for your calculators to put as a fraction. $752 out of 132,600 tries. That's literally a 0.5% chance that that will happen. If you want to put that in some real life context there. That if I give you a deck of cards, that you get a 2, 5, and not a 5 in that order, and keep the cards as you go along. 0.5% chance. Good luck on that. All right, 0.5%. How are we doing here? We all right? Okay, here we go. Oh, Jane, she's going to Chicago. The chance her flight's on time, 90%. On the same day, rain in Denver is 50%. So what's the probability that Jane's flight will be on time and it will rain in Denver? Do you think these are independent or dependent, these two events? Does one have any effect on the other? Being on time in Albany to Chicago to raining in Denver? No, and don't be that kid like I had a couple kids third period. Well, what if she went from Albany to Denver to Chicago? What if she started in Denver? Just stop. Okay, just stop, please. It's ridiculous. So yes, these are independent events. And how many events are there? How many events are occurring here? So you know you're going to do what to these probabilities? Multiply them. I know that sounds like a broken record, but you'll see why I'm a broken record in a second when it changes. So let's go on time. What's the probability she'll be? The flight will be on time. Flight will be on time. What's the probability? 90%. How do you want to write that? 9 over 10, 90 over 100. I don't care. Guys, if you want to put 0.9, go ahead. And that it will rain in Denver. What's my probability of raining in Denver? 1/2, 50 out of 100, 0.5, however you want to write it. So the probability that both happen? 9 out of 20. Anything at all before we go to the toy bin? All right, let's go. Let's dive deep into here. What do we got? Toy bin, 12 toys. 8 stuffed animals, our favorite. 3 board games. What do you think those board games are? I'm going at least Chutes and Ladders and Candyland. Any others? Monopoly. Somebody said that third period. Monopoly. Not a big fan of Monopoly. They change it too much. Even old school. It's like all digital now. You got an ATM card and ridiculous. And they're getting rid of the old pieces and putting in new pieces. No thanks. Like I rubber, I think, in the spring of last year and got rid of like the thimble. How can you get rid of that one? It's classic. There's just too many versions. I'm sure there's a Delmar version or an ridiculous. All right, anyway. And why do I ask your opinion? What's the probability she picks 2 stuffed animals out? So hey, ready? Guys, how many picks is she making? She's making 2 picks, right? So I know I'm going to have to multiply. Doing 2 or more picks, 2 or more selections. All right, 2 stuffed animals. Probability she gets a stuffed animal out first. Braden, what do you got? Stuffed animal out first. How many stuffed animals are there? 8 out of how many toys or total things in the bin? 23. Now here's where kids have a problem. They don't see the term without replacement. They don't see with replacement at all. So what should I do? Well, guys, how many stuffed animals do you need at the end here? 2. So if you put the 1 back and you pick a second time, you're only going to have the 1 at the end, right? So what do you have to do to that first stuffed animal if you want 2 at the end? Keep it. You got to keep that. If you want 2 at the end, if I take a stuffed animal out, it's total. Why would I have a stuffed animal? You take 1 out and you put it back in, and I pick 1. I'm only going to have 1 at the end, right? Everyone agree? Actually, I do. Never mind. It's embarrassing. There goes my street cred. You need to keep the first one. So now, how many are still in the bin? I kept that first one. How many are still in the bin? 7 out of 22. It's the only way you're going to get 2 at the end is if you keep the first one. $28 out of 253. One last thing before we move on. If you're doing anything selecting, picking 2 or more, you got to do what with your probabilities? Multiply and watch out for with and without replacement. Okay? If they're independent or dependent. Are we good here? Because I got to go on to something else now. We all good? Independent, dependent. All right, before I move on, let's go to my die. Everybody, I'm going to roll this once. Once. Is it humanly possible that when I roll it once, to get a 3 and a 6 at the same time? Is that possible, to get a 3 and a 6 on one roll at the same time? No. So because I cannot do it at the same time, I'm going to call those events mutually exclusive. They cannot happen at the same time. Hold it. Picking 1 card. Lucas is going to pick a card. Is it possible for him to pick a 2 and a queen at the same time? No. So picking a 2 or a queen is what we call mutually exclusive. Why? Because they cannot happen at the same time. Okay, 2 events that cannot happen at the same time with 1 pick. See the difference now? We're only picking once. Look at my first example, number 8A. I'm going to roll a die. What's the probability I get a 3 or a 5? Guys, can that happen on the same roll? No, that's why this is mutually exclusive. It can't happen on the same roll. You guys already know the answer, right? What's the answer? 2 out of 6, right? Or 1/3? But where's that come from now? Ready? Where's that come from? How many times am I rolling? Once. So no more multiplication. Adding the probabilities now. All right? Adding the 2 probabilities. Ready? Here we go. Emily, what's the probability I get a 3? One roll, I get a 3. 1 out of 6. Anna, what about getting a 5? 1 out of 6. You add those fractions, keep the numerators the same. The denominators the same. Add the numerators. That's where that 2 out of 6 comes from. Okay? And again, how many times did I roll? Just once. All right? So if I'm doing something once, or if you see that word or, I'm going to start adding them. Okay? Let's try it again. Rolling less than a 3. What's the probability I roll less than a 3, Vinny? 2 out of 6. Alex, what's the probability I roll a 6? 1 out of 6. And I'm not multiplying because I only rolled that darn dice once. So that's why I'm going to add them together and get 3 out of 6. Okay. What if they have something in common? A 4 or a spade. Could that happen at the same time in a deck of cards? A 4 or a spade. Yeah, what's it called? 4 spades. A king or a diamond. Could that happen at the same time? Yes. So those events are not mutually exclusive. All right, they are not mutually exclusive. So I am still ready. I'm still going to add because I'm only picking once, but I got to do a little something different at the end. Watch. For number 9, find the probability of picking a 2 or a diamond. One pick. That's it. One pick. So let's go through this again here. Brienne, ready? Picking a 2. 4 out of 52. I see the word or. I'm picking once. Here we go, Annika, picking a diamond. You remember how many diamonds from yesterday? 13 out of 52. But now we have to do something different. We have to subtract that, how many times these are in common, a 2 and a diamond. How many cards are in the deck that are a 2 and a diamond? How many? 1. So I have to subtract out that 1. And I know that doesn't make sense right now, so let me explain it to you before you find out the actual probability. Picking a 2. Ready? I'm just going to do it. Don't write it down. I'm just going to do it real quick for you. I could go what? 2 of hearts, and you can make fun of me later. I don't care. 2 of clubs, 2 of spades, or the 2 of what? Diamonds. Or picking a diamond. Everyone ready? 2 of diamonds, 3 of diamonds. I'm not going to keep doing this. 4 of diamonds. There's a problem here. I counted the same card twice. Does everyone see that? I counted the same card twice. I can't count it twice. I can only count it once. So that's why I'm subtracting off that 1. Guys, do we see that there? Can't count the same card twice. All right, that's going to throw off the probability. So that's why I subtracted what they had in common. So out of 52, what do you got for me? 17 minus 1. 16, that's what I thought. Reduce it for me. Go ahead, reduce it. Matt, let me know what you get when you reduce it. Four over 13. So if they have something in common, we got to subtract it out. All right, we got to subtract it out. Okay, here we go. 10, and then it looks like you guys are going to do one on your own. Go ahead, read through it. Read through it in your group. I don't care. Read through it in your group about the insurance company. What types of insurance can I get here? What types? Car or home, right? 2 different types of insurance. Notice at the end of the problem, how many customers are going to be picked at random? A customer, 1. So that tells me right off the bat, hey, we're going to add these problems, add something together, all right, because a customer is going to be picked. Okay, find the probability at least 1. Can you please discuss with each other what at least 1 means? If you have at least $5 in your pocket right now, what's that mean to everybody? In your pocket right now, you have at least $5. What's that mean? You have $5 or more. So what's at least 1 mean? You have one of the insurances or more. Okay, so you have one or more of the insurances. All right. Reagan, name one of the insurances that's available. Car. How many people have car insurance? So as a fraction, I can write that as 56 over 100. So they could have car. Brooke, what else could they have? Home. How many have home insurance? So plus, because there's only one customer I'm looking at. But aren't there people here that I've also counted here? There's people who have both car and home, right? Everyone agrees with that? There's people I'm counting twice here. How many have both, Cooper? So what should I do with that 18%? Subtract it from the people who have each one. Yep, 18 out of 100. Because remember, there's 18% here that are in both of them. Lucas, let me know what you get. How many have at least one or more insurances? 86 out of 100. And again, guys, you want to leave it like that. I'd probably prefer you reduce it to 43 out of 50. Or some of you might say, heck, everything in the problem is percent, so why don't I leave it as a percent? That's fine too, 86%. Isabel, what am I looking for in the next one? Probability that they have, neither. So they don't have any insurance. They don't have neither car or home. Sorry, I had to figure out which one. Car or home. So either car or home. So no car or no home. Right? Still doing addition because it's one customer. Megan, you ready? No car. How many have car? So can you find me how many have no car? How'd you get that 44 for everyone in your class here? Right? Everybody else. There's 56% that have car, so that means the other percent, 44, have to have no car. Braden, how many have home? So that means how many don't have home? 52. Aren't there people who have both? Vinny, how many people have both? Oh, they'll have both. Have both. You're getting ahead of me there, champ. 18%. So how many don't have both? 92? Watch your math there. All right. Maybe you can raise your pant leg a little higher. You'll know it. 82 out of 100. Yes. Okay. Long hair, don't care, right? What do you guys have? 7? 7 out of 50? 14 out of 100? Okay. So 14%. Now, hey, because I'm going to let you guys do this next one on your own. But before you do that, can we just think for a second, if you're on a test or quiz, and let's say you totally botched, you forgot about the both, can you please add 44 and 52, and what's going to happen? Actually, don't. Never mind. I thought it was going to go, never mind. Forget it. I thought it was going to go over 100. This one goes over 100 if you add these two, and can't have a probability bigger than 100%. So sorry on that one. All right, but are we okay? Thought I was going to make a good teaching move there, but totally backfired because I can't add. That's 96. Questions? Okay. Fine, I'm still going to go because I'm not going to give here. Even if you add those, you get 96%, right? 96% have neither. What did you just find in the last problem? 86 have at least one, and 96 have neither? How does that make sense? Everyone see that? All right, you can't have 86 have at least one of them and then 96 have neither. I think that goes over your total of 100% just a bit. Okay, yeah, I got it. Let me see you do 11 on your own or in your group. I don't care. Go ahead. How many students are being picked? A student, right? So you know, ding, 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 I got to add. Or you see French or stats. So you see the word or you're just picking one person, you know it's an addition run. About 60 out of 100, 60%, 3 out of 5. Okay, somebody, let's go. Not joking around. Get an answer key up. Let's get going. All right, I want to see you working on these for the next 10 minutes. I may have to sit with some groups here to make sure here. Go ahead, Megan. Hold on. Let me stop this.